Hello, once again we are back with the NASA IPAC NextSci Star and Exoplanet Database looking at the Exoplanet Transit Survey Kepler Search web page, and we are going to look at the stellar data of something a little bit more complicated than the eclipsing binary star that we looked at before. I'm going to enter the Kepler ID of this object. It's 8005468. Once again, 8005468. I've entered it into the Kepler ID field, and I'm clicking the View button right now to retrieve the data sets that are available for this particular star. There are 4 data sets available in both long and short cadences. Remember that the long cadences are integrations on the Kepler instrumentation of about 30 minutes, and then the short cadences are 1-minute integrations. And we can also look at the time ranges of each of these data sets. This one is from 54953 Julian date up to 54963 Julian date. It's about a 10-day period. The next one goes from 64 to 97, roughly 30 days, and then from 02 to 91. That's a nice long period to look at, and from 64 to 91, another 30-day period for the short cadence. I'll start with this one, more or less randomly looking, and just plot a light curve for this particular object. And we get a light curve, and it's a little bit messier than things we've looked at before. Once again, flux on the y-axis and Julian date on the x-axis. So let's go and compute a periodogram for it and see if the software thinks that if there is a period or not associated with this star's brightening and fading over time. And here's our periodogram. Definitely not as neat and perfect as our eclipsing binary star. There are no thin, strong periods denoted here on our power spectrum whatsoever. We have a thick one though, roughly around 8.5 days with a power of about 301. So let's go ahead and plot the phased curve for that. And lo and behold, a really ugly looking mess. Definitely not a function, definitely not a well-calculated period, and definitely not consistent whatsoever. Oh, while we're there, close that one down. Let's look at the phased curve for some of the other periods. Here's a period of 3.54 day. Click it and see what it gets, and we're back to a really ugly looking phased plot. So what to do, right? Well, if you go back to the original light curve, you'll notice pretty quickly that there seem to be 2 different styles of light curve going on here. There's one that looks almost periodic, like a sawtooth of some sort, and then something that gets a little curvy and bumpy afterwards. So about the first third or half of the data looks almost periodic, and then after that it gets pretty messy. You do have a tool available to you here that allows you to plot periodograms just for certain ranges of data in terms of time, in terms of the Julian date. So let's go ahead and pick the range from the beginning to, which is right up here. The beginning is 54964.5 Julian date. And I'll just copy that up to about 54978 or so. Now remember, this is 70. 72, 74, 76, 77, right around in here. But you have to add, according to this note, you have to add 54900 to it. Just a hint. So let's go to the periodogram viewer. And on the right-hand side, we can select a constraint of the Julian date and enter the minimum date here. And then we enter the maximum date range that we want to search for, which is 54978.0, and hit submit, and it will try to create a new power spectrum for us. And it may complain because sometimes we choose data that's outside the range and capacity of the computer, and sure enough it's doing just that. Here it has highlighted a field under period range, and it says problem, processing request, your period range max may not exceed 26.97, which is twice the time spanned. Okay, let's delete that and enter its maximum, 26.97, and say submit one more time. And this time it should be pretty happy, and it should give us a new periodogram. And here is our new periodogram, and it's given us one very high power peak. But then again, it's also not very thin, which means that the period here on the y-axis is not well determined. It could be anywhere in between these values. So it's not a well-determined period. But it may be better than nothing at all. The period's roughly 6.42 day or so. So let's look at a phased curve of that and see if it looks better than the messes that we had before. And sure enough, it is a little bit better than before, but it's not perfect. It's showing us that there are some ranges of periodicity going on during this section of the star. And in fact, you can see that the peaks don't even reach the same height level, and the depths are inconsistent as well. They seem to be declining before it goes off into this jumbly mess. At best, we say the star is quasi-periodic. That's about the best we can do for it, given this data set here. But we can go look at some of the longer data sets if we would like, and we should do that. Here's the longest one from 55002 to 55091. So once again, go create a light curve for that 90-ish day period. And lo and behold, we do have kind of a mess here. We have a star that has this odd bouncy activity in terms of brightness. Seems to be going down and then may even be tending to go back up. Don't worry about blank spots like this. It's just areas where data were not collected by the Kepler mission. Let's go ahead and compute a periodogram, and I think you can guess by now it's not going to show us anything perfect. It's going to show us probably a bunch of very thick peaks. And sure enough, that's pretty much what it did. It's given us a high power peak here at 88.7, which is way off the scale. Definitely not even worthy. And then we look at something that's more or less around 6.57 again. It's pretty close to the period that we had before. And if we click the phased curve for that, we get something that's pretty messy. But you can see it's trying to be periodic around 6 days or so, 6.5-ish days. And then all the rest of this stuff scattered all over the place, making different periods, shows that the star is quasi-periodic at best, if it's periodic at all. So now that you have some more tools to deal with some of the more complicated stars that we may run into during our study of all the thousands of stars in the Kepler mission, I hope this has helped.